You are sorely mistaken if you think being inside a sturdy tank, amidst a formidable army of hundreds, makes you safe. You'll never know when the pristine white clouds above might suddenly be ripped apart by a tempest of firepower raining down upon you. Rows of armored vehicles suddenly burst into flames, the origin of the attack unknown. It's truly a feeling of utter helplessness. Indeed, this was likely the very reality faced by Iraqi soldiers during Operation Desert Storm in 1991. So, who was the perpetrator? None other than the tank killer itself, the Boeing Ah-64 Apache. Gliding silently like phantoms, these iron dragonflies lock onto their targets with electronic eyes before unleashing precision-guided Hellfire missiles. One after another, Iraq's proud tanks exploded into fragments, transforming advancing spearheads into giant infernos. The Apache's destructive power enabled coalition forces to swiftly defeat Iraqi forces and liberate Kuwait by the end of February 1991. Its resounding success in the Gulf cemented the Apache's status as the world's premier attack helicopter for decades to follow, prompting numerous nations to seek to acquire this aircraft. This video will unlock the secrets of the Ah-64 Apache, exploring how it became the world's ultimate tank hunter, an aircraft capable of turning picturesque roads into highways of death. The origins of the Ah-64 Apache. The world's most formidable attack helicopter rose from the ashes of a canceled program. The Ah-64 Apache's trip from concept to battlefield dominance started in the early 1970s. Military necessity and rigorous competition shaped its development. The emergence of the powerful Apache helicopters was driven by costly lessons learned in the brutal Vietnam War and the serious challenges the United States military faced during the Cold War. They had to find a way to counter the overwhelming number of Warsaw-packed tanks that could push through the Fulda Gap or the North German Plain into Western Europe. They needed a specialized aircraft that could improve their anti-armor capabilities. Envisioned as a new weapon system to meet the Army's demanding requirements, the ambitious Lockheed AH-56 Cheyenne program was ultimately canceled in August 1972 due to ongoing development setbacks, including technical difficulties and significantly escalating production costs. Nevertheless, the United States Army still required a helicopter far more capable than the AH-1 Cobras employed on the Vietnam battlefield. The Army launched the Advanced Attack Helicopter Program on August 17, 1972. This program called for a more practical design than the complex Cheyenne, with a top speed of 145 knots, twin engines to improve survivability, better firepower and performance, greater range than the AH-1 Cobra, capability to fly nap-of-the-earth missions. The Army's vision was straightforward. They wanted a helicopter that could conduct attack and reconnaissance missions, support ground forces, and contribute to the success of military operations by locating, reporting on, and engaging enemy forces. A competition among the big players continued, including Bell, Boeing Vertol, Hughes Aircraft, Lockheed, and Sikorsky. After initial evaluations, the Army selected Bell and Hughes Aircraft as finalists in June 1973. Both companies received contracts to build 2 prototype aircraft, starting Phase 1 of the competition. Bell created the Model 409, designated YAH-63, while Hughes developed their Model 77, designated YAH-64. The tight deadline pushed both teams. Hughes YAH-64 took its first flight on September 30, 1975, with Bell's YAH-63 following just 1 day later on October 1. The Army tested all 4 helicopters extensively throughout 1976. Hughes YAH-64A emerged victorious on December 10, 1976. Both designs showed promise, but the Hughes helicopter proved superior in survivability. The Army praised the YAH-64 damage-resistant 4-blade main rotor and stable tail dragger landing gear configuration over the YAH-63 tricycle arrangement. Hughes built 3 pre-production AH-64 as for additional testing after their win. The Army gave full production approval in 1982, and the first Apache rolled out in 1983. The name Apache followed the Army's long-standing tradition of naming helicopters after Native American tribes. Army General Hamilton Howes started this tradition before the Air Force separated from the Army in 1947. Military historians note that Howes saw similarities between helicopter tactics and tribal warfare. He noticed that helicopters would attack enemy flanks and fade away, like in the way the tribes on the Great Plains fought. The Army made this naming practice official in 1969 through Army Regulation 7028. The Apache name fit perfectly because of the Apache tribe's renowned warrior spirit and combat skills. The name honors the Apache people's brave fighting during the Apache Wars, the longest war in United States history. Early engineering challenges and breakthroughs. Building a groundbreaking attack helicopter meant tackling huge technical challenges. The Ah-64 Apache's path to becoming today's powerful gunship was filled with engineering hurdles that needed creative solutions. The Apache program hit a major snag early on with its main rotor blades. The Army wanted a blade life of 2,200 hours, but the blades failed at around 800 hours because the bond line epoxy joints holding the spars started unzipping. While helicopters could still make it back to base safely, this created huge maintenance headaches and expenses. Manufacturing wasn't any easier. Hughes helicopters had to reject half of all produced blades due to spar disbonds, which led to major delivery delays. The team fixed several manufacturing problems, including blade cure profile issues, cleanroom assembly shortfalls, epoxy shelf life, and pot life issues. But the troubles continued. Engineers finally found that there was a root cause. Drawings didn't properly specify the bond line width where spars were glued together, leading to too much variation. The fix came by setting stricter component tolerances than the original engineering documents required, which made sure bond line width stayed above the crucial 0.375-inch mark. The Apache's power kept improving throughout its development. Today's AH-64E models use powerful T700GE 701D engines paired with an upgraded face gear transmission that engineers redesigned to handle more power output. These changes boosted climb performance while keeping the helicopter's 186 miles per hour top speed. The advanced improved turbine engine program promises to extend the Apache's reach even further. The T901 engine will let the aircraft fly 135 nautical miles to a target, stay there for over an hour, and return safely. This is a big deal as it means that the current 30-minute loiter time will more than double. Keeping crews safe was always the most important priority. The design includes multiple defensive features, self-sealing fuel tanks filled with nitrogen to prevent ignition when damaged. Electroslag remelt metal in the airframe to absorb incoming rounds. Kevlar armor plating beneath pilot seats is capable of withstanding 23 millimeters of projectiles. Ballistic blast shields between pilots to enhance crew survivability. Redundant systems are positioned throughout the aircraft to maintain functionality despite battle damage. Modern Apaches also use the helicopter Integrated Defensive Aid Suite, which automatically spots hostile weapons and launches appropriate countermeasures without the pilot's input. The Apache's biggest breakthrough came with the successful integration of the AGM-114 Hellfire missile system. The AGM-114R Romeo variant brought a revolutionary change to air-to-ground weapons by combining precision, versatility, and destructive power. The Apache Longbow Revolution. The AH-64 Apache went through its most important transformation in the mid-1990s. This remarkable upgrade turned an already powerful attack helicopter into something that would change battlefield operations forever. The AH-64D brought groundbreaking combat capabilities when it entered service. This upgrade fixed the original Apache's limitations and made it much more effective in combat. The Apache Longbow marked the first major overhaul since the helicopter's introduction. The Army and Boeing started their development work on the Ah-64D program in the mid-1990s. Their upgrade package brought major improvements to digital communications, electronic warfare self-protection, and engine performance. These changes created what many experts see as an entirely new helicopter. The Apache Longbow proved its worth in combat soon after deployment. The Ah-64D became the Army's top attack helicopter with its signature 30mm cannon and ability to carry up to 16 AGM-114 Hellfire missiles. The NAPG-78 Longbow fire control radar stands at the heart of the Ah-64 DTCS transformation. This remarkable system is the only fire control radar in the world fielded on an attack helicopter. The millimeter wave radar system sits in a distinctive dome above the main rotor and has changed how helicopter combat works. The radar's capabilities are game-changing capabilities, simultaneous tracking of up to 256 moving and stationary targets, prioritization of the top 16 targets for immediate evaluation, detection in adverse weather, obscured conditions, and at night. Recent upgrades have doubled detection range from 8 kilometers to 16 kilometers, quadrupled detection volume compared to original specifications. The radome's position above the main rotor lets Apache crews spot targets while staying hidden behind terrain, trees, or buildings. This gives crews an unprecedented advantage. They can identify threats without exposing themselves to enemy fire. The Apache Longbow's most valuable tactical advancement was its fire-and-forget missile system. Pilots no longer needed to maintain a laser lock on targets throughout the missile's flight path. This change meant helicopters spent less time exposed to enemy fire. The AGM-114L Longbow Hellfire works as a true fire-and-forget weapon with millimeter-wave active radar homing. The missile needs no guidance after launch and can even lock onto targets after firing. Pilots can now fire and immediately take cover, which helps them survive better in hostile environments. The system loads target information into the missile before launch, including coordinates, radar measurements, and velocity data. The missile guides itself using gyroscopes, accelerometers, and onboard active radar homing after firing. The system works well even in conditions that would stop laser-guided weapons, like smoke, fog, and poor visibility. This versatility helped greatly when enemies tried to use environmental factors against American air assets. The Ah-64 DTCS capabilities keep improving today. The latest Ah-64E version 6.5 brings better lethality, survivability, situational awareness, navigation, and communication. The upgrade also creates a common operational flight program software baseline for all Apache E-model helicopters. Inside the Apache cockpit, the Ah-64 Apache's cockpit showcases military engineering at its finest. Human and machine work together in perfect harmony inside this extraordinary workspace. Years of refinement have created a design that maximizes battlefield effectiveness and crew survival in the harshest conditions. The Apache stands apart from regular helicopters with its tandem seating arrangement. The pilot sits behind and above the co-pilot/gunner. This setup gives both crew members clear views while presenting a smaller target to enemy fire. Both positions come equipped with complete flight controls. This allows either crew member to fly the aircraft when needed. The redundancy has proven valuable in combat when one crew member becomes unable to fly. While both stations have controls, only one person can fly at a time. A formal handoff procedure transfers control between positions. Control transfers happen through an electronic request system between positions. The first person's controls become inactive until transferred back. This smart system prevents dangerous situations where both positions try to control the aircraft at once. Each crew member can access almost all other aircraft systems besides the main flight controls: cyclic, collective, pedals, and throttle. This shared capability helps distribute workload during complex combat missions. The integrated helmet and display sighting system stands as the Apache cockpit's most innovative feature. This breakthrough technology works as protective headgear and a sophisticated targeting platform. Critical flight and targeting information appears right in front of the pilot's eyes. This creates an exceptional link between human perception and weapon systems. Apache crews gain several tactical advantages, shows up-to-the-minute targeting imagery and symbology to the pilot, reduces pilot workload during complex combat maneuvers, boosts situational awareness in all visibility conditions, serves as the main targeting mechanism for weapons systems. The integrated helmet and display sighting system lets crew members slave the helicopter's 30mm chain gun to their helmet movements. The gun points wherever they look, almost like an extension of human instinct. Military engineers call this zero time to target acquisition. Weapons and loadouts. The Ah-64 Apache stands out as the world's deadliest attack helicopter with its impressive weapons. This flying arsenal packs both precision-guided munitions and area-effect weapons to take on threats from the ground and air. The AGM-114 Hellfire missile serves as the Apache's go-to anti-armor weapon that can destroy heavily protected targets. Each helicopter can carry up to 16 Hellfire missiles on 4 4-rail launchers attached to wing pylons. These missiles pack a devastating punch with ranges between 8 and 12 kilometers. Apache crews can hit threats from distances well beyond most ground-based air defenses. The modern AGM-114R Romeo missiles now come with multipurpose warheads. These combine high-explosive anti-tank power with fragmentation effects. The Hellfire works well against many targets beyond tanks' light armor, bunkers, and even low-flying aircraft. American Apaches have shown they can shoot down drones using these ground attack missiles. Apache helicopters carry the Hydra 70 rocket system in 2 19-tube launchers to suppress areas and hit multiple targets fast. These 2.75-inch folding-fin aerial rockets offer budget-friendly firepower against battlefield threats. The Hydra system's value comes from its building block design. The rocket has 3 main parts: the Mk-66 MOD-4 rocket motor for propulsion, a choice of 9 different warhead types, associated point detonating or remote set fuses. Mission planners can mix and match Apache loadouts for specific missions. Warhead options range from high-explosive anti-personnel to anti-tank, multi-purpose submunition, and flechette types. Special warheads can light up the battlefield, mark targets, or create smoke screens. General Dynamics has made over 4 million Hydra 70 rockets since 1996. These rockets support rotary wing air missions across different service branches. Many helicopter types can use this system, which helps maintain consistent capabilities. The Apache can defend itself in the air by carrying FIM-92 Stinger missiles. These heat-seeking weapons sit on the helicopter's wingtip stations. Apache crews now have a fighting chance against enemy aircraft and unmanned systems. Stinger missiles have proven themselves in combat with over 270 successful hits on fixed and rotary wing aircraft across 4 major conflicts. The air-to-air variant protects Apache helicopters from enemy aircraft that could threaten their operations. The United States Army started updating Stinger missiles with proximity fuses in 2019. This upgrade made them much better at taking down small, unmanned aerial systems, a growing battlefield threat. Missiles can now destroy drones through direct hits or nearby detonation. The Apache's arsenal includes the powerful M230 30mm chain gun under its forward fuselage. This automatic cannon holds 1,200 rounds and provides steady firepower against light armor, vehicles, and personnel. A typical combat load might have 8 Hellfire missiles with 2 Hydra 70 rocket pods. Mission needs determine the exact setup. A fully armed Apache becomes a versatile platform that can take on everything from main battle tanks to infantry positions and aerial threats. Armed with this formidable arsenal, the Apache soon proved its mettle on real-world battlefields. The Apache in real wars. The Ah-64 Apache has proven its worth time and again on the battlefield. This formidable attack helicopter has joined almost every major American military operation since it entered service, showing its dominance consistently. The Apache wrote its name in military history during Operation Desert Storm with a legendary mission. 8 Apaches from the 101st Airborne Division's 1st Battalion struck Iraqi radar installations at exactly 2:38 a.m. on January 17, 1991, in a mission called Task Force Normandy. Air Force MH-53 J-Low helicopters supported this precision strike that destroyed Iraq's early warning network in just 4.5 minutes. This created a corridor for nearly 100 Allied aircraft to slip into Iraqi airspace undetected. The Apache fleet showed remarkable resilience during Desert Storm. A total of 277 Ah-64s joined combat operations and kept a 90% readiness rate despite the harsh desert environment. These helicopters destroyed 278 tanks and many armored personnel carriers, with over 500 total kills. Enemy fire brought down just 1 Apache, and its crew made it back safely. Apache is headed to Afghanistan in 2001 for Operation Enduring Freedom after the September 11 attacks. These helicopters stood out as the Army's only platform that could provide accurate close air support during Operation Anaconda. They took frequent hits, yet quickly returned to combat after repairs. The Apache has faced both successes and setbacks during Operation Iraqi Freedom in 2003. A failed attack near Karbala on March 24, 2003, left 31 Apaches damaged and 1 shot down. The fleet bounced back quickly and provided vital convoy protection and ground troop support throughout the conflict. Several Apaches were lost to enemy fire and accidents by the time United States operations ended in Iraq in December 2011. The Pentagon sent Apaches to Baghdad in July 2014 to protect embassy personnel from militant attacks. These helicopters started missions against Islamic State ground forces on October 4, 2014, as part of Operation Inherent Resolve. The Iraqi Army's Mosul offensive got support from Apaches in 2016. These helicopters provided night combat capabilities during the battle to take back the city. The 101st Combat Aviation Brigade tests Spike NLAWS missiles on their Ah-64 Apaches in Iraq. This new weapon pushes the Apache's strike range to 32 kilometers, 4 times farther than the Hellfire missile. This gives better protection against sophisticated air defenses. Modern upgrades and future tech. The machines of war must evolve with warfare itself. Boeing's continuous modernization keeps the legendary Apache gunship as the leading battlefield technology through the 2060s. The gunship adapts to new threats through ongoing improvements. The Ah-64 Guardian stands as the latest advancement in Apache technology. This variant has improved lethality, survivability, and network connectivity for multi-domain operations. The version 6 configuration brings major improvements to sensors, software, and weapons performance. Boeing upgraded to version 6.5, which makes training and maintenance more efficient by creating a common software configuration across the fleet. The Army's first modular open systems, architecture-compliant enduring aircraft can now integrate new capabilities in months instead of years. The active electronically scanned array radar system represents the most important upgrade under development. The active electronically scanned array's electronic beam steering capability outperforms mechanical radars with faster and more precise target detection. The United States Army tests wing-mounted active electronically scanned array radars on the Apache's outrigger-style pylons. The radar's capabilities include fire control and terrain mapping, help you navigate in poor visibility, airborne hazard detection and terrain avoidance, shoreline mapping using augmented reality techniques. The active electronically scanned array radar boosts the Apache's maritime operations significantly. Version 6 update has optimized the Longbow fire control radar to hunt ships more effectively. Apaches can now detect, identify, and classify vessels by size in various sea conditions. The improved turbine engine program brings revolutionary performance improvements. GE's T901 engine delivers 3,000 shaft horsepower, 50% more than the T700 engine, while keeping the same size and weight. Apache crews can now conduct missions at 6,000 feet and 95 degrees F, with 2.6 times more range and payload capacity. The T901 integration lets Apaches operate more efficiently with better fuel consumption, less maintenance, and reduced logistics requirements. Boeing has implemented open architecture systems through modular open systems architecture, which the Army considers a key modernization priority. This approach quickly integrates emerging technologies like launched effects and advanced flight controls. These systems reduce pilot workload and maximize the Apache's safety, lethality, and performance in all conditions. To this day, the Ah-64 Apache remains a benchmark, regarded as one of the most formidable attack helicopters ever built. Although programs exploring future vertical lift concepts are underway, there are currently no immediate plans to retire this battle-hardened workhorse. Instead, the Apache continues its relentless modernization to maintain its battlefield edge. We will likely witness even more sophisticated, upgraded versions taking flight in the coming decades. But the battlefield never stands still. In your opinion, what upgrades are most critical for the Apache to maintain dominance in the era of sophisticated air defense missile systems and the rise of unmanned aerial vehicles? Should it be advanced active defensive suites, deeper integration with UAV swarms, or even more increasingly potent engines? Share your analysis and predictions in the comments below. Would you like us to make more videos about other types of helicopters? If so, please like the video. Thank you for watching and see you in the next videos.